Welcome everyone to the June edition of the Grand Rapids Drupal Meetup. Today we are doing our second part of our discussion on Drupal services and dependency injection. And last month we covered what services are in Drupal 8 and 9 and how they compare to the way things were done as a standard in Drupal 7, and a little bit about why it's a good idea to use them, what they can be used for, how you find them, those kinds of things. And this month, we're going to springboard off of that conversation into some of the more implementation details as a developer, how you access these services in the code that you're writing, and how to do it using the pattern that Drupal asks you to use called dependency injection, which Dan's going to go into some detail on why we do that, and we'll get into specific simple examples of how to do that in the real world in various different cases. So without further ado, I'll hand it over to Dan, who's going to give us a primer on what dependency injection is.
Yeah, we're going to try to keep this pretty brief because, as Jonathan mentioned, the prior month we went into it more in depth. But dependency injection is a fairly common now programming technique that most modern platforms and languages support. And the general idea of it is that I don't want the code that I'm writing to be dependent on knowing stuff about other code. And the reason why I don't want to do that is because it makes my code fragile. So if that other code changes, I've got to know about those changes. In particular, if I'm using the constructor to, using the new class name syntax to create new instances of those things, I've got to know all of the things that are passed into the constructor, and may have to create those things, which may also have dependencies that I have to create, and it can cascade, et cetera, et cetera. So dependency injection is a way of saying, let the system or framework figure out how to create one of those things and give it to me. So it's, rather than me being dependent on it, the dependency is injected into my code. That's where the name comes from. So again, it's a way to make my code less fragile by not needing to know as much about the code that I'm using, and don't need to know how to create those things or where they exist, and I don't need to deal with changes to those things.
All right, yeah. And so last month we showed how you can find the services that Drupal and contributed modules provide. And I'm going to give a real quick recap of that before we dig into the implementation part, so that we can talk about things in a little bit more practical detail. So I'm going to start by sharing this screen and show that in this this is an example of a page in a Drupal 9 site that is provided by the Devel module, which I recommend that you install locally, maybe not in production, but locally for any Drupal site you're developing, because it has a lot of handy tools, one of which you'll find under the heading container info. It's maybe not obvious that that's where you'd look for services until you kind of understand the terminology that the word container has something to do with services. But once you know that, you can find it again. And the container has in it services, and it has parameters. We're going to be talking about services today. So services are by ID, give you an instance of a particular class, and this listing will always give you all of the registered service IDs and the corresponding class that you could look up for the details of what that service provides for you. Just as a quick technical detail there, this is telling you the specific class that is currently serving that service for this Drupal instance. So it's not giving you the interface that service ID promises to provide, but rather the specific class that's serving it. That is often a detail that you can overlook, but could be important sometimes. But basically, if you're looking for something Drupal can do, this is a good place to start.
Yeah, and there's a couple things to note just looking right here on the screen. So the point of dependency injection, going back to my summary, is that I don't really want to have to know about those classes. I want to just be able to know the names of these services. And in fact, if we look at the very first one, it's that service functionality is provided by this access arguments resolver factory. But by using the service name and letting it inject whatever dependency that means, it means that class could actually change to something completely different, and my code does not need to change whatsoever. And that brings up the key point about interfaces. So when you're using dependency injection, it's kind of a cardinal rule that you should always code against interfaces for that very reason. So I don't want to really need to know anything about that specific class. And often, I should say almost always, when you're talking about Drupal, the interface is just the name of that class followed by interface. So if I were going to use that access underscore arguments underscore resolver underscore factory, I probably in my code want to code against an access arguments resolver factory interface.
Right. And so in my examples, just to keep things as simple as I can, I've written some examples just using a very simple service Drupal provides, which is time. So routines about the current time. So if you search for, actually, I'll search for date because we'll use some of these others as well. So there is a service with the ID of datetime.time, and it shows that this is the class that implements it. And if we look in the Drupal API documentation and we look for that class, we will see that right here in the hierarchy, just like Dan's saying, it implements time interface. And if we look at that, this is going to tell us the functions that, regardless of whether it's using that time class or something else, we're guaranteed that these 4 functions are going to be present. So if you're in some situation where, I don't know, maybe you need a replacement service in your case that pretends that you're in a different time zone for all purposes for some reason. I'm making something up, but you could implement, you could implement, or you could grab a module that implements a class that behaves just like the time interface you're used to, but under the hood does some different things. And even so, you're guaranteed that since it follows this interface, it's going to have these methods that accept the same parameters and return the same results. So I'm using this one because it has very simple methods. For example, this get request time, which is going to give you the timestamp in seconds when the current page request began, which may not be the current time. So this is a reason you wouldn't just use the PHP time command, because you want it to give you a consistent time if you call this twice during the same page request. So we're going to use that as an example. So yeah, that's a refresher of how you can find some services. So now let's look at a particular example, and I am going to go to a simple page. Okay, so This is a page that is being output by a module, and I'm going to walk us through the code here. And just to look at what the output of this page is, it's simply a single paragraph tag with the current time stamp in it, or the request timestamp in it. So let's go to the code and look through how this works. So this code file is every page in Drupal that comes from a module is going to be served up by a controller. And a controller is a type of class that extends usually from controller base. And it will have, among other things, at least one public method that returns a render array for constructing the current page. And if you want to know more about render arrays, there was a recent recent Meetup session you can look up on YouTube where we talked through how those work. And in order for this page to be served up, we have a YAML file called routing that says, when you go to the path example/simple page, we want to load up this class simple page and call the method page. And this also tells you who can see it. In this case, it's anyone with the permission to access the content. So that is enough to get Drupal to spit out the contents of this render array. But you'll see the value of this paragraph is calling this getRequestTime method that we just looked at from this thing called time service, which is a member variable of the current class. So the question is, how do you get that service? And last month we looked at how you could do that procedurally by calling the Drupal namespace class method of service that can pull in a service by name. But now we're going to talk about how to do this in a more accepted pattern of dependency injection, where we're not going to say to Drupal, hey, give me something with this name. We're going to allow Drupal to supply that to us, and therefore maybe supply us something else. And also give us the opportunity to, in testing, swap out a different implementation of that class, or there are other reasons that's a good thing. But let's just take as given the fact that we want to follow the established pattern and see how to do it. So what we need to do is get an instance of something implementing that time interface, whether it's that class or something else, and we need to get it stuck into this member variable. And the way we do that in a controller is, first we have to define the member variable where we're going to put that service. And here you can see that we have defined it as something that satisfies this time interface. Rather than saying it is that time class, we're saying it's anything that follows the interface. In our case, it will be the time class, but we don't have to know that. And so we've declared that there. And then we have to give Drupal a way to give us a copy of that. And we do that by defining this function, this method called create, which is a special name. That is a name that controller base knows about. So because we're extending from that base class, we don't have to do anything else special. We just define a create method with this signature. And inside it, the first thing we do is let the parent implementation, which is the controller base one, give us a copy of a controller that it made. And then we just add to it by saying our time service is going to be the value that the container gives us for something called datetime.time, which we're guaranteed by the contract that Drupal has provided will be something matching the interface we asked for. And then we just return the result. So that is a lot of words to describe 3 lines of code. And if you needed more services than that, you would just declare more protected variables up top and add more lines to this create method. And then those will be available to you for the duration of your controller's lifetime. So yeah, so this is what I was trying to do here, was boil this down to the very simplest possible toy example, because one thing I find whenever I'm looking anything up, I find a lot of real world examples that all do really cool things with edge cases, and that muddies the waters for me in understanding what is actually required. And as far as I know, this is the minimum required to do this in an accepted pattern. And this is, I should have prefaced this by saying this, we're going to go through 3 examples, because in my experience, the dependency injection use cases boil down to 3 different reasons, or 3 different situations. One is a controller, which is a very specific case, but also probably the most common case for typical developers, where you're just making a page that you want to display. The second is going to be making your own service and then wanting to inject another service into it. And the third is going to be a Drupal plugin where you're inheriting from some kind of plugin or defining some kind of plugin and want to inject a service in there. So apologize, I should have started with that framing up front, but this is number 1, which is the case of a controller where we're defining a page that wants to use a service. And I'll just go back real quick to the output of this. I wish I had a very simple way to switch between these, and just showing again the output that we expect to see, which is the timestamp in seconds of the current page request. And that's all that's being spit out by this, but that's not coming from a PHP call to the current time. That's coming from our service that we asked for.
And Jonathan, why don't you flip to your container services tab there, just to show that name of that service.
Oh, yeah, right. So back to here. Yes. So once again, I asked for datetime.time, and it gave me an instance of this time class, which is why I was able to call that method on it. All right. So Dan, do you have any other examples of this type of thing you want to show?
Yeah, I have one really good example of that, and it's, I just got to make sure I get to the right, and then move this because we don't want an infinite mirror here. So just to go just a little bit more under the covers, just something Jonathan touched on. So the reason why we can use this create method like this is that our controllers are going to extend from controller base, and controller base implements this interface, container injection interface, which will be important in a minute here in the further discussion. But that interface only has one method in it, and that's the create. And if you look at the code comment here, you can see that this is specifically for creating new instances in the context of dependency injection. And one other thing I want to say, I meant to say it back when you were showing that devel services list, is this concept of a container. So if you're new to dependency injection, container is a term that's used generally in dependency injection. And in the dependency injection context, it means the container of all of the registered services, or all of the registered things that can be injected. And again, container is a commonly used term. in all kinds of languages and platforms that do dependency injection. So in this case, what Drupal does is if it is a class that implements that interface, it will inject into that class the registered list of services so that you can do things like this get. And this example here specifically is sort of a practical real world case of why dependency injection is useful. And that is that this project in real use on the live site used accessed an Oracle backend system. And I am developing on a new M1 chip, Apple chip, and Oracle's extension for accessing their databases does not work yet on the M1. So what I needed to be able to do was detect whether I was running on a system that had that extension available or not, and use either use the real service or use kind of a mock service. And dependency injection allows me to do that because I can say I'm not really coding against that specific class that is going to try to make those Oracle database calls. I'm just going to program against the interface, and then my mock implements that same interface. So this code all through the rest of this entire application can not care and not need to know anything about the service that's providing that data. The code is exactly the same, whether it's using the mocked data or whether it's using the real data. And again, going back to the introduction, that's the whole point of dependency injection. I don't want my code to need to know anything about the details that are going on under the hood. So if we have time at the end, we'll get into a little bit more of that with factory patterns, but that's kind of not for right now. We don't need to get into that, but this is an example, and it's following it's the same 3 lines of code essentially that you just saw Jonathan demonstrate. It's a different service in this case. In this case, this is a service that this module actually defines, which we'll also get to in a minute. But other than that, it's the same code. But again, this is a real world example of why dependency injection was really useful.
Now, there's one difference in that my version made the instance by calling parent create, and yours is using new static. Is there any distinction there we need to talk about?
In practical reality, there won't be, because new static just means call the constructor on this class. If we boil down to controller base, you'll see all it's doing is returning new static. So
okay,
in this particular case, from a practical standpoint, there would not be a difference.
But if you're not inheriting from controller base directly, and rather you're inheriting from something that, like, if that chain was longer, you'd want to make sure to use the parent probably to get all of the things that it did, if anything.
Yes,
it's just
generally that's probably a better practice. I just happen to know, because I was deep into the weeds of dependency injection and figuring this out. I just happen to know for controllers in this simple inheritance case, it doesn't really make any difference. But you're right. The better practice is probably to always, in general, that's true for coding, like always use parent whenever you're overriding a method or a constructor. So.
Yeah, and I think we'll see another example a little bit later where this distinction might matter.
Yeah.
Yeah.
But that's good to point out. Yeah.
Great. Okay.
So do I need to relinquish control?
Nope. I think I can take it over just fine. All right. So next I am going to move on to case number 2, which is going to be us defining our own services. So first off, why would you want to do that? Well, Dan covered one example, but a simpler reason you might want to define your own service is there are still a lot of places in Drupal that you have to do things procedurally, where you have to define a hook in a module. And there are plenty of reasons you want to do as little as possible in that land and get into object-oriented land as quickly as you can. And an easy way to do that is to find your own service and call it. And then you can do the rest of your work inside the service and use all of these features that we're used to. For the purpose, so for the purposes here, I'm defining a service, an example service, and what it's going to do is kind of a slightly more sophisticated, sophisticated in big air quotes, version of what we looked at before, which was getting the current request timestamp, but this time we're going to format it nicely for human consumption. So to do that, I should start here. The first thing we're going to look at is the interface that we're going to write for our service. So this file, if you've never written an interface before, you can see it is a pretty simple affair. You give it a namespace, and the namespace typically for most services is they're just going to live in the top level source directory. You can put them in subdirectories, but this is a pretty common pattern. And you declare it as an interface and give it a name. And again, the convention is the name of your service class with interface at the end. That is not enforced, but I don't see any good reason to deviate from that standard. And then you define all the functions that are going to be public, but instead of giving the code for what that does, you just put a semicolon there. So that's all there is to making an interface. And it's not at all a bad idea to start here when you're writing a service, because this way you can spend the time to think about how do you want people to talk to this service. And by doing that, you can get your head around, okay, what really is the important, what is the important promises that I'm making to people using this service? And in this case, the promise we are making is that there will be a function called get current date. It will return a string, and I should have done a better job of a comment here. I should have said something like provide the current request time as a nicely formatted date. Okay, so there we have an interface. So then we have to actually tell Drupal that this service exists, and we have to write the service class. I'm going to bounce back and forth between these things. So first I'm going to show you defining the service or declaring the service to Drupal. So this is in the services.yaml file in your module. And you have to give your service a name, and it is convention to start with the name of your module and a dot. That way you can be sure that nobody else is going to step on the same name that you have defined. It's kind of a simple version of namespacing right there. And then you have to give a class that actually defines the implementation as opposed to the interface. So here is the name of the class that we're going to define without interface at the end. And then I'm going to come back to this third line that says arguments. So let's go back to now the actual service itself. And you'll see here that we're defining this class and saying it implements the interface that we just defined. Then afterwards is something that looks pretty similar to what we did with containers. We have a couple protected variables that you can see are declared to be instances of these interfaces, date formatter interface and time interface. And I'll come back to this in a second, but down here at the bottom is the implementation of the method that we promised that we would provide. Get current date, it returns a string. How does it return a string? Well, it calls the format method of the date formatter, which expects to get a timestamp. And that timestamp is going to come from the get request time service, just like we did with the controller. So to make this work, we need those two member variables to be filled with awesome service objects. And we do that here in the constructor for the service. And we say this constructor needs to take in something that conforms to the date formatter interface and something that conforms to that time interface. And whatever the person constructing us gave as those two arguments, we're going to stick into these member variables. That way we don't lose them after the construction and can actually use them later. We could do something, there are instances where you might not save the object that came in, but you might do something with the object and save the result. That does happen, but this is the point of this is to do the simplest possible case. So we got handed a couple things, we'll save them, and then later when get current date is called, we will use them. So the one thing to point out that's different than the container example I showed is that while we say we're implementing our own interface, we're not saying that we inherit from anything. Services we define ourselves can just be simple bare bones classes. They could inherit from things, and there are good reasons to do that. But this is the simplest possible example once again. And then the other thing is, how do we tell Drupal what to give us for these two items? And this is a place where we're trying to give these examples as the current practices that work as of summer of 2022. And the landscape of internet searches for how to do these things is littered with how you used to do these things. So there are things you might find that are no longer applicable, but this is going to be, again, the simplest possible case. You go back to your services YAML file and look at the arguments, and in the same order as our constructor, it says which services we want and an @ sign in the front of them, which is the terminology. We might go into a little more detail about what that does, but basically that's what you're normally going to see to let Drupal know, I want a service by the following ID.
As opposed to a literal string, for example.
Yes, because arguments can be other things that would come into the constructor, right?
And we should note, just in passing, Jonathan, that those other, we're showing you the current in the sense of it being the simplest. So a lot of those old examples were way more complex than what you really need to do. So again, as of now, this is kind of the simple way to do this.
Right. Exactly. And so now we've asked for those in our services file, and then those come in automatically to our constructor where we save them, and then later we use them. So I'm just going to give a side-by-side example of this service with the simple page we talked about before, which really the big difference is this one is using this create method, and that's because of controller base, as Dan was saying, using this container injection interface pattern, whereas the service, because we are declaring it as a service, we know the only way it's ever going to be made is by Drupal looking at that service's YAML file and calling our constructor. So this is actually probably the simplest in terms of understanding what's going on, because you've declared all those things in one place and you use them. It's a little bit more of a hassle because you're bouncing back between two different files, the services file and the actual code. Some other frameworks would do some introspection of the data types that you gave the constructor and do some of that stuff automatically through something called auto wiring, which is something you might find when you're looking for examples. But this is the simple way to do it today. And then just to look at that in action, I'll go back to my browser. I should learn from my experience that I should close all the other windows, because going back and forth in the Zoom interface is a little bit painful. Okay, so we go to examples / custom service. And here we have this formatted version of the current date and time is being displayed instead of the timestamp, because our services are doing what they're supposed to do. All right. So Dan, do you have any other examples of that style of thing?
I think I've got some good stuff to sort of add to that. And if you are here watching this looking for, very specifically looking for very high level introduction, just ignore everything I say, because I'm going to dig a little bit deeper. And so again, just to reiterate, put a fine point in this, we are creating this service so that it can be injected into other things. So we want to be one of those things in that list of services that other code could then inject into it. And in this case of this application, I was experimenting with two different ways of doing something, and it was a pretty complex problem of creating the ability to have menus associated with groups from the group module. And there were two kind of competing ways to do that. And I didn't really know which one would work the best until I coded them and tried them and found the gotchas. And so services in injection provided a really cool way to make that as painless as possible, in that in this case, Jonathan mentioned he didn't know why you would ever name the interface differently. Well, this was a case. So I have a menu manager service interface that's different than this class. And that's because I have two classes that implement this interface. And I want to be able to just switch between the two of those. And by having two services, or two classes, I should say, that implement this interface, in my services definition, I can just change this class name here to swap them out one for the other. And because I'm coding against the interface, I can swap the actual implementation out and see how that works, and then flip back to the other one and so on. But all of the code that's consuming this never changed. It's all identical because I'm coding against the interface. And so again, that's why coding against interfaces are important. And this is another kind of practical example of why dependency injection and services are useful. And in this case, as you can see, it's the same syntax that Jonathan just showed you. One little gotcha here I just thought of, because we actually recently had a developer I had to help with this. So this is YAML, and the arguments is an array in the syntax of square brackets. So the other developer got a little hung up in that he was thinking JSON, and so did squiggly brackets, and was thinking of it being an object, which is a list of items, a JSON list instead of an actual array with square brackets. So just this specific exact syntax is very important.
So that probably means that you could do it as multiple lines with a dash in front, since it's YAML, and it would be the same. Yeah,
I'm not familiar enough with syntax, YAML syntax to do that, to know that is the case. So you're saying you can do this?
Yeah, and then exactly that. I think that's the same.
probably
just-
is.
Yeah.
That would
This
make
is
sense.
this is the common way to do these arguments. There usually aren't very many of them. And so it's
Yeah.
compact.
Right. And so I did want to just show this service because it's a little bit of a spin-off on this concept of creating your own service. So these 3 lines do create my own service, but there's no corresponding code. And all I'm doing with this declaration is saying this service, my service, is actually inheriting, in a sense, from logger.channel_base, which is a Drupal service. And in this case, as we said, why this little ampersand is important, in this case, the argument is just a string literal, which in this case is my channel name. So this allows me to say, to define a new service that doesn't really have any code behind it. It's just saying, create one of these things, passing this literal value into the constructor. And then the value of that is that then all throughout my code, I can inject this service, and all of my logging now throughout my entire module all uses this same channel without me having to have this string all over the place. And then if I ever want to change this channel that I'm using for this module, I've got to go find all those places and do a search and replace. Whereas this way, because I'm injecting this service, I don't need to know that detail. So again, this is going back to the introduction. Why do we use dependency injection? Because I don't want my code to have to know anything about the details. For example, what the name of the channel is that I'm using for logging. By injecting the service, it's all taken care of under the hood for me. And this is how that's used. just like consuming any other service, I can consume that service in my own service.
Nice. All right. One thing that came to mind from something that Dan said that I should have shown, that the fact that the service we defined does show up under these container services. This ID that we defined does in fact have a class. So that's just demonstrating that no matter where the service comes from, you can find it in this list, which is very useful.
Yeah, and that just reminds me, again, you just touched on it before I shared my screen, but Drupal dependency injection is more complicated than it is in other languages and frameworks. And typically, you mentioned the auto discovery. Typically in other frameworks, there's more auto discovery where I just put a class in my constructor and it's just magically appears when the code runs. So just if you're coming from other languages or other frameworks that do dependency injection, and some of this seems kind of weird to you, it is a little more complicated than you might be used to if you are already used to dependency injection.
Yeah, okay. And I think that brings us to our final category of things. It's the most complicated, but it's still going to be fairly simple in our simple examples here. And that is plugins. Plugins in Drupal, very briefly, are classes that Drupal is able to discover through its annotation mechanism and become options to use within Drupal's interface. So common types of plugins include field types, field widgets, blocks, lots of things like that. So as a very common example, we're going to make a custom block. So a custom block is a kind of plugin that has an annotation here that says block, and you provide the ID of the block and you give a label for the block, and that's all that Drupal needs to be able to show that as something available to be placed on the page. It needs to extend from block base, or more specifically, it needs to implement the block base interface. But usually you do that by by the block interface, but you do that by extending from block base usually. Yeah, block plugin interface, you can see block base implements block plugin interface, which is all you need to be able to do to have a block, but you get a lot else for free if you extend from this base class. So usually you're going to do that. And inside your block class, you must have a function called build that returns the content of the render, returns the render array you want to place in that block. So really, it's almost identical to our controller example, but instead of implementing block base, we're the controller base, we're implementing block base, and we have a specifically named thing build. There are other things you can implement, but this is, again, trying to be the very simplest possible example. So we're again going to print our nicely formatted date, and I'm putting everything together here, and we're going to do that by using the service we defined before. So this time, the service that we're going to try to inject here is the one that we wrote. But much like Dan's examples, we're saying that we could swap that out for something else that satisfied the same interface later, and we wouldn't have to be any the wiser. So we want this example service member variable to get filled out by Drupal with something that fulfills our interface so that we can call getCurrentDate on it. And we're going to do that by implementing the create method. And this create method has a little bit more going on than we have seen before. It's a lot like, if we go back to our simple page example, we had a create method there that all it took was the container, which is what we need to care about in order to get services. But since this is a plugin, its parent class requires certain information to be given to it. In particular, it needs the current configuration of the instance of this plugin, needs the ID of the plugin, it needs the way it was defined, and blocks are an example of a class that doesn't already know about dependency injection by itself. So we need to tell Drupal, hey, this can have stuff injected into it. And we do that by saying that we are going to implement the container factory plugin interface. And that container, if we go to the definition of the container factory plugin interface, we can see that that consists of one method, oops, I'm scrolling too fast, one method called create, and that's it. So we need to make sure that we have this function in our actual code definition. So we implement that, and what it needs to do is make a single instance of this plugin. And we do that by calling the constructor of the parent, basically, of the class, and giving it the things it's expecting, the configuration, plugin ID, and plugin definition that were passed in to us. And then doing, after that, the same thing that we did for our controller. Once again, I'll compare that, where we filled in things from the container using get. We do exactly the same thing here by getting our custom service by name and then returning the thing that we made. And so because we implemented this interface, Drupal looks for whether that interface has been implemented or not. in order to know whether to call create on it. And if that has been implemented, then it will call create and give you the filled out container with all of its service objects inside it, and allow you to do this work. And then we have an instance of our example service, which itself gets things injected into it, but we don't have to care about any of that stuff in here because that's all done behind the scenes by the container. And then when we actually do our build, we can just call the get current date without any of the other services even being mentioned in here. So then just to see that in effect, to show that it works, we will go back here and we will just look at the block that we have implemented down here that is in fact showing the same date as the page itself did. So once again, very simple example. And yeah, anything else you want to add to that, Dan?
Yeah, well, interestingly, I did that slightly different too in my example. I do have an example of the old style and just the complexity of all of this code compared to what Jonathan just showed you. And in particular, you have to really know a lot of details about how your parent class is constructed. And this is an example of this more simple current recommended approach. Interestingly enough here, I also did not do the new static here. And so the static function is related to the self function. Those two go hand in hand and just work differently with inheritance. But static just gives you an instance of the current class, which should be effectively the same as calling, as doing new homepage block. And those three things are passed into the constructor because those are the parameters that the inherited or parent class expects.
Yeah, I believe that they are in fact identical in this case. I just use static in that case because it's one fewer thing that needs to change if the name of the class were to change.
Yeah, and I think that's the big advantage. I think it's just a kind of abstracted way of doing this. But for that very reason, I can change the class here and I wouldn't have to change this code as well. This here is an example of something Jonathan mentioned earlier, where I am injecting into this the request stack, but all I really want is the current request, which is something that the request stack returns. So this is an instance of I'm not really just setting my internal or protected variable equal to the service that I'm getting. I'm actually calling a method on the service and then storing that, as opposed to doing straightforward just storing the service itself. So Jonathan mentioned that earlier, and this is an example of doing that.
And I think the reason you do that versus not doing that really comes down to the same reasons you would make a variable in any code. If you're going to be using that current request more than one time in the code, then there's no reason to repeat that get current request every time.
Yeah, exactly. Yeah. And there is no service for the current request. So this is the way you have to get to it. You have to go through the request stack service. Or in some cases, you'll find that the exact thing that you need. And I've done this a lot in the case of entity type manager, for example. So all my code really uses, and it uses it all over, is node storage. So rather than have to say, get the node storage from the entity type manager, I just do that in the constructor like this. And what I actually store is the node storage, so that I don't have to have that code retrieving the node storage all over my code. In this one, I probably only use it one place, so it's probably pretty unnecessary in this example. But node storage is one I commonly use, where I'll use this technique to avoid having that extraneous code all over the place. And there was one other thing I wanted to mention about this, but I don't remember what it is right now. So
And that's okay, because as usual, the 15 minutes of content that I
Yeah.
had prepared is an hour long. So yeah, there's more that we can say, and maybe we'll have a more advanced session in the future where we can go into that in more detail. But I think it's probably worth wrapping up here, because I think anyone trying to digest this information will have plenty to chew on already. So we'll be posting this as usual to the YouTube channel, and we'll have, I think we'll probably be putting the example code that I wrote up on, probably up on the Rapid Development Group articles. Likely we'll be putting these simple examples for posterity there, if you wanted to look at the code in a non-video format. But other than that, I think we'll end there. And as usual, call for any nominations for topics or people who want to speak. Feel free to put that in the comments on the Meetup group or the YouTube channel. And we will be off in July for Independence Day, and then we will see you again in August. Thank you very much.